I know, it's hard to believe that we finally get to the point where we're going to do something. There was so much upfront prep that I was trying to teach people, so here we go. We are going to build a simple superhet transceiver, first conceived by Wayne Burdick in 6KR, and we're going to try to get you and myself to build ones that looks a lot like Dave Richards' AA7EE, and everything you need to know is on his webpage. Just go to your search utility and go look for AA7EE space SST, and you will get the web page devoted to that build. Now, all this information, including this schematic, including the manual for the original Wilderness radio. So you choose which one you're going to build. I know a lot of you want to build the original. The only difficulty with that is that there's a video chip and you have to go to Mauser or DigiKey to get it, the LT1252. I'm going to choose JH1PJL's version, and Dave has a link to this schematic and then a picture, but the pictures are just thumbnails, and the Wayback Machine didn't save the originals. Now they may be somewhere. If you see them, just drop me a post and I'll point them out. So I'm going to be using this schematic, and I'm going to do some mods. First of all, I showed you a video using the adapter boards from eBay and using SOP8 integrated circuits for the LM386 and the 3 NE602s. So here are the breakout boards. I did them on my little hot plate technique, and here's the 386, and then here's the mixers. Also, I'll be using these little homemade 5 millimeter by 5 millimeter square pads to build this thing on a printed circuit board. Okay, the Wilderness radio has 4 band configurations: 40 meters, 40 meter novice. Does a 40 meter novice even exist anymore? It may be taken over by digital signals, but then I don't know. I haven't been up there. But you're a general class or extra class license, so you shouldn't have any trouble working down in the lower end. Everybody's scared, but if you can do 10 words a minute, 12 words a minute, 30 words a minute, 50 words a minute, doesn't matter. Oh, another thing about QRP work, you can't do 50 words a minute. What happens is your spectrum, your signal is spread out over an appreciable bandwidth that your signal level at whatever tone they tune in is going to be so weak. So you don't need to go fast. It's detrimental. Okay. Now here's your homework. Now I'm not going to do all this for you. The purpose of this exercise is not for me to build an SST to get on. I'm going to get on 20 meters. I am going to build it, and I am going to get on 20 meters with it just to prove that at 950 milliwatts, I'm going to set the power low. There's a little power adjust somewhere. Where is it? Somewhere there's a power adjust. We'll put one in there. I'm going to show you can do a lot, especially now that the solar cycle is pretty good. And we got to do this in a hurry. First thing you do is you take this schematic and you figure out the blocks. For instance, there's a receiver mixer. There's a variable crystal oscillator, and it's the heart of this beast. It sits there, and whatever frequency you choose for the band you're going to use here, that's what this oscillates at. And there are two outputs coming from this one point. There's one part that goes to the transmit mixer, and there's another part that goes, here it is, goes to the receiver mixer. So that's one block. There's a receiver mixer. Signal comes in, gets beat against the variable crystal and the receive signal, and comes out at the IF frequency. Goes through an IF filter, and I added this as a block. It's not important, but anyway, divide this thing up into blocks, and then figure out what you think goes with this label. So we got an IF filter. The crystals here are dependent upon which band you get. Then there's a product detector, which takes the signal here, beats it against the IF frequency. It's off a little, generates a tone. Then that gets amplified by the audio frequency amplifier, and then you set the gain, because you might get a loud signal, you might get a weak one. You'll crank this up, and then it goes to your headphones, speakerphones. This thing's not, well, it'll drive earbuds and whatever, but for those of you who want to use a speaker, you're going to have to use a amplified one. Okay, that takes care of the receiver. And then for the transmitter, when you transmit, you key down, and that activates the, well, we'll look at it. It activates the transmit mixer, which mixes the VXO frequency with this mixer frequency. And note that this is the IF frequency, and this is the transmit mixer oscillator. Notice it has an inductor in series with it. What this does is this lowers this frequency. So whenever this thing transmits, the receiver mixer is not going to be on the same, so the tone that you hear is whatever the difference is between these two crystals here. And if you don't like the tone, then change this little inductor. And there are several values. If the frequency is too high, then make this lower so that the shift is smaller and it gets closer. Oh, excuse me, that makes it lower. Increase this. Now, now you can't just willy-nilly put any value in here, because there is a possibility you put a 47 microhenry in here and the oscillator stops working. Then you're going to have to change these caps. We'll come back to that. But anyway, so this transmits now at the new frequency. There's a bandpass filter here, and just so you can eliminate harmonics and bad stuff. This may do the job. There's another filter out here. Then this goes to a buffer driver. This is going to be, 600 millivolts, well, some, volt, whatever it is. It gets amplified here. Then drives the PA transistor, and then goes through the low pass filter so that only the band that the frequency that you want to transmit on is the only thing goes out. And we're going to change this. Steve Ratzlaff, AA7U, down in Tucson on QRP Tech, the IO groups, came out with a new one that'll meet new FCC regs. And I'm going to do a couple of things here. Now, again, there's some part issues, like this is a 2SK 241 JFET. You'll say, what in the heck is that? Well, Google. Download the data sheet. We're going to use the J310. I was going to do a 3904 or an ASH10, but I'll go ahead and stick with the group, and I'll do a JFET, but I'll come back and do another one. I'll do a second rig. So it's just a JFET. We'll just substitute. Don't be afraid of substituting here. You just May have to change some values here to get it to oscillate. I'm going to do 20 meters, so my VXO frequency here starts at 18 megahertz. And my IF is going to be 3.932 megahertz. 3.932 were difficult. I couldn't find them on AliExpress, so I had to go to Mauser to get them. And the same here. This is just an NPN. I'm going to try something here, and I'm going to substitute a Darlington pair so that I can get more gain. If you go back to Wayne Burdick's original rig, the LT1252 video amp, it has a gain of around 38 dB. You're not going to get that out of a single transistor. But with just a 3904 or a 2N4401, any NPN here, you'll probably get at least 1 watt out. But if you want more, then you're going to have to do some finagling, and you may generate higher harmonics. So it's a win-lose situation. The 2SC799 is an old CB transistor. They're hard to find now. I'm going to use a 2SC2706. You can get them for, I think I got mine for 18 cents a piece. They're cheap, and they'll take a beating. You can get them from kits and parts. Okay, so we've got this broken down. Now the next thing you do is we're going to lay out a board. You have to choose a board size. And I'm going to go 100 millimeter by 100 millimeter. This is about the same size, but almost exactly the same size that Dave did. And I've got the diagram set up so that each module, I'm going to plug my headphones in here, and then I have the gain control. All this is on the front panel. The audio amp goes here. The product detector and the BFO section goes here. The IF filter goes here. And then the receiver mixer goes here. And then the low pass filter goes here, and then they connect to your antenna. VXO's here. I'm going to put in a keyer just like Dave did, and you should just go find you a keyer. Kits and Parts sells a keyer that was in the 1W5W series, 1 water. There are hundreds of things around, so pick a keyer, or you don't. You just go put a plug in here, and you can use your bug or your straight key if you're a member of SKCC, and that's what you want to do. Anyway, signal from the VXO goes through the transmit mixer, goes to the buffer driver, goes through the PA, goes through the low pass filter, and then out the antenna. So this is going in, and this is going out. So here on my front panel, I've got the audio here, the tune is in the center, and I put, because it's in the middle, I put the VXO in the middle. That way the leads from the potentiometer to the PCB is fairly short. For the keyer, now this is just first pass. I may move the speed over here. Move the speed control up here, put the command button here, and then the key, 3.5 millimeter jack here. You decide that. On the back, I've got the antenna. I haven't decided on where the power goes. So you can do this, do your own, figure out where everything's going to do. Now for each section, I want you to draw a block diagram, and then I want you to show me where the power, show if it requires power. Like the bandpass filter doesn't require a power, this bandpass filter, low pass filter, whatever. Where are you going to put this regulator? And I'm going to use a LM7808 because I'm going to put 8 volts instead of 6 volts. everywhere. Now there's one other mod that let me tell you about it, and you can figure this out. Note here that this little the tune pot right here, has 8 volts across it. It effectively only is used to change the voltage across the varactor diode, and that's how you tune it. If you want more tuning, then you're going to have to add a part. You can add a resistor with a 10 volt Zener, or you can get a 78L10 and put 10 volts on this thing and get a little bit more tuning range. Some other people are going to put 2 crystals in parallel here to get a larger tuning range. One other thing I'm going to do, okay, now for example, here's my IF filter. Dave, in his layout of the SST, put them in series along the board edge. I'm going to put mine in a little block configuration here. Got crystal, 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 input, output, and the filter capacitors are between the 2 crystals. So there's 1, 2, 3, 4 caps. I didn't draw, I just put the schematic symbol in there, save some time. And this little block takes 7 by 3 or 21 squares. The whole board takes up 1,000 squares. That's your area limit. And take each block, figure out the parts, and draw this diagram for that block, and then figure out how much area it's going to take. Cut it off your little sheet of paper and paste it in here, or make another one and paste it, and make sure before you even lay down one pad, you know where everything's going to go. It's going to save you some time. I was going to say something else about the pad things. Oh, this notebook, or this paper I'm using, is 5 millimeters by 5 millimeters, so that I can, when I draw this thing, that's where a pad is going to go, and then when I go and lay it out on the board, I have some idea where to put the pads. You do that. Another thing, if you in your layout you don't think you're going to have enough room, one of the things is that I believe everything's used in here is a quarter watt resistor. Not that many resistors, are there? Are there any? Yes. Yeah. These bias resistors, they're quarter, but you could substitute 1/8. On the capacitors, you can use mono, and those things have got a 5 millimeter spacing, but if you use a small disc cap, they've got 2 millimeters spacing, 2.5, and then 5 for the monos. So you can save some space there. Most of these inductors, if you look at the Wilderness Radio, these are molded inductors. They are half watt. I don't know if you can get quarter. I got half, and I got 1 watt, but this thing doesn't run any power, so you can use everything on the low end. The Zener diode here gets you a 33 volt or whatever, and the purpose of this Zener diode is to protect this transistor. Now with the 2SC2706, you could do without this. Oh, speaking of doing without, I'm almost through. See this little section here that I marked in orange? First of all, this little green LED is just a power LED, because this is 8 volts coming from the regulator going to here, and there's no way that voltage there is going to change. It's 8 volts, that's why we got the regulator there. That's why we got these capacitors here. That's why we got these electrolytics here. So this is just a power indicator. This other red LED, when this point right here goes to the key jack, it's floating. When it's floating, this transistor here sitting here doing nothing. There's no current through here, so there's no applied voltage here. This thing just sitting here and the red light's off. Now when you key, now we got this transistor biased, goes full on, current flows, this red light comes on. So when you key, this little red light is going to flash. Now there are warnings on movies, you know, they got ratings R, you know, PG or whatever, and then if you watch, like I watch on Prime Video, they'll say flashing lights. Evidently, this can be a problem with some afflictions. So I'm going to do without it. I can save the power. I'm going to take this out, and I'm going to take this out. I'm going to leave it on 24/7. We'll talk about that when I get to operating. So I'm going to remove all this stuff. That saves some parts, and we'll make some other mods, and I'll do them as I go along. So your job right now, is to, you know, do your homework and get the layout and everything. Now, section by section, as you lay it out, print off about 1 to 6 copies of this thing. Go to, if you don't already have them, go and buy a 6-pack of highlighters. You can get them for less than $10 off of Amazon. In fact, I think you can get, for $20, you can get a 32-pack. They only come in 6 colors. But anyway, as you take each section, highlight each item and then write it down on another sheet of paper or type it into a spreadsheet, and you're going to do your own. I'm not going to do it for you. Bill of materials, and highlight each one by one and write it down what it is. And if you're going to substitute, if you're going to change bands, if you're going to change the JFET, you're going to because of the band change, you're going to change these 2 caps. Do this as you go along. Then, after you get all the sections done, you probably want to go through here and make a list that has only the resistors, only the caps and everything. And then if you don't have a part supply, you're going to have to go out and order all this stuff from Mauser or DigiKey or your favorite vendor. And you have to do this section by section. I'm going to do it. I don't have to buy anything because that's what I've been doing. That's why it's taking me so long. So I believe that I have everything I need. Another thing, on this variable resistor here, it says 10K. All it is a voltage divider. So if you have a 20K or a 50K or a 100K, it'll work just as well because there's no current drain across here. You know, it's measured in microamps. So, you know, it's just a voltage divider. It's not critical. I think I've covered everything. Hope you have learned something from this. And I probably left some stuff out. I'll do that as I go along. So I'm going to give you, how much time do you need? Let's see. Let me give you 2 days. Today is Sunday. Wednesday. I'm going to come back Wednesday because I'm going to go off and do this stuff. And when I come back, I will have the VXO built. And I'll have figured out where my power is going to go. Look at Dave's layout and you'll see where he did, you know, a straight line red wire that carried his 12 volts and 8 volt power supply to the various sections. Get you a vanilla folder. Here's the low pass filter values from Steve AA7U. Okay, what happens is it looks like the regular low pass filter from the SST, but he's added these caps across the 2 inductors here and changed the values. And there's probably some online app that helps you do that. I don't know where it is. And I'll just trust Steve to do that, and I'll save me some time. Thank you for your time. I shall return. Please like, and please go to your desk, get your pen and paper, pencil and paper, typewriter, computer or whatever and start doing the analysis, because this is the fun part. Thank you very much, and talk to you Wednesday.